This is Mr. Gilliam, and today we're going to start learning about ratios and how to compare values. And I guess to know how to do that, we need to know what a ratio is. Basically, it's a comparison. Okay, you can rewrite it as a fraction. You can use a colon, but it reduces like a fraction as well. And so a ratio, one example would be 1 to 2. It could also be written as 1 to 2 or 1 to 2. Okay, it all represents the same meaning, 1 to 2. Okay, or we could have 4 to 5, also written as 4 to 5 or 4 to 5. Okay, and these are ratios, and we're going to do a little more work with them, but I just want you to be familiar with what I'm talking about when I say ratio. I'm talking about that thing with the colon, or you can think of it as a fraction, or with the word 2 in the middle. Some ratios, though, like 2 to 6, 2 to 6, or 2 to 6 could also be reduced. So instead of 2 to 6, I could call that 1 to 3, or 1 to 3, or 1/3, 1 to 3. You wouldn't say 1/3, you would say 1, 2, 3. And so they do reduce just like a fraction. If they have a common factor, you may reduce by that factor. Let's just do one more. If I had 5 to 20, that could be written as 5 to 20, or 5 to 20 like that. But really, we know it would be the same as 1 to 4, 1 to 4, or 1 to 4 like that. Okay, and so I want you to start looking at ratios and remembering that you can reduce them similarly to a fraction. Okay, but basically what a ratio is a comparison between two things. And so I'm going to give you some examples here. If I were to write an example for each of these ratios, I see that the first one is 9 to 3. So when Mr. Gilliam thinks about 9 to 3, one thing that comes to mind with that ratio would be 9 months in school to 3 months out of school. All right, so that would be a ratio of time in school to time out of school. That's what I notice. Some ratios, depending on the context, are better. I mean, you can emphasize your point a little better if you leave the numbers without reducing them. But it would make sense if it was, this could also be 3 to 1. It would make perfect sense as well that 3 months in school, 1 month out, 3 months in, 1 month out. But because we don't actually go 3 months in and then 1 out, 3 in, 1 out, it would make more sense to leave this ratio as 9 to 3 because we do go 9 months in and then 3 months out. So depending on the context of the problem and what point you're trying to emphasize, what real life situation, sometimes it is more appropriate to leave it as 9 to 3 instead of changing it to 3 to 1. Same way with this 5 to 10. When I think of 5 to 10, I think of, well, maybe in one of my classes, if I have 15 students, there could be 5 boys to 10 girls. And so that one maybe would be more appropriate to write 1 boy for every 2 girls. But it just depends on the context of the problem or the example that you come up with, because you'll have a few examples that you get to come up with tomorrow on the worksheet. So be thinking about, it's just a relationship between how many of one to another. So I hope that kind of defines ratio a little better for you. Sometimes, so like here's some hard examples. You have pictures here on this one, and there's actually 2 problems here. They kind of got squished together a little bit, but it says what is the ratio of moons to circles? So I'm going to say moons to circles is how I'm thinking about it. So I guess the first thing I need to do is figure out how many moons there are. I have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15 moons. And I see 1, 2, 3, 4, 5, 6 circles, 15 to 6. So 15 to 6 is the ratio of moons to circles. But a better ratio would be, if I divide both these by a factor of 3, 5 to 2. Okay, and now you could write that 5 to 2 as 5 to 2 or 5 to 2 like that. But really we're trying to emphasize with the colon today. So you can think of it as those other two forms as well, but we're going to really try to write our ratios with the colon in between. This next one says, what is the ratio of pentagons to circles? Okay, well, let's count the pentagons. 1, oop, that's not a pentagon, 2. So pentagons to circles. So I see 2 pentagons, and I see all the rest of the stuff is circles. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I see 12 circles. So in this case, my ratio would be 2 to 12. But the best answer would be 1 to 6, or 1 to 6, or 1 to 6. But again, we're trying to emphasize that ratio with that colon in there for now. So the ratio is just comparing how many of one to how many of another. Okay. You might be given a problem like this, and you get a little multiple choice action here. It says you have diet sodas and regular sodas. We have 2 and 9. I'm going to say diets and regulars. And before I get too carried away with reading all these answers, I'm going to say I'm going to write the big D and the big R on there so that I don't get confused about what's going on. Okay, and so in this question I could have 2 different ratios. I could have diet sodas to regular sodas, or I could have regular sodas to diet sodas, just depending on which comparison I'm trying to make. If it were diet to regular sodas, my ratio would be 2 to 9. If it is regular sodas to diet sodas, I would call that the ratio 9 to 2. Just depends on which order we're comparing. And so when I read through these questions, it says the ratio of D to R is 2 to 9. Well, let's see here. Okay, that would make sense. I already wrote that down, so I like A. The ratio of diet sodas to regular sodas is 9 to 2. Okay, well, I disagree with that because diet comes first and regular comes second. It should be 2 to 9, so B is out. For every 2 diet sodas that are sold, there are 9 regular sodas sold. Well, that doesn't really make sense either. Oh, well, yes, it does actually. For every 2 diet sodas, there are 9 regular sodas sold. That would make sense, 2 to 9 as well. And then the ratio of regular to diet is 9 to 2. Oh, well, I did the regular to diet ratio over here, 9 to 2. That one would make sense, okay? And so I like to write the ratio and then compare what each thing says to make sure I get the correct answers on there. Let's take a look at the next one here. It says large popcorn, so I'm just going to abbreviate that L, and small popcorn's S. So when I'm comparing just these 2 things, I could compare large to small, or I could compare small to large. And if I'm comparing large to small, I have 6 large and 9 small. So it could be like that. And if I was doing small to large, it would be 9 to 6. It's just the number associated with the small compared to the number associated with the large. Okay, so depending on the order that I'm comparing is going to change my ratio a little bit. Now part A says, okay, and actually I'm going to go through here and just write the big L and the big S on there so I can keep track of what's what. I think it's just a little easier for me to see. Okay, it says the ratio of large to small, so L to S, is 9 to 6. Okay, well I don't think so. I think it should be 6 to 9 because there are 6 large sold and 9 small sold, so I think A is a no-go. It says for every 6 large popcorn sold, there are 9 small popcorn sold. Okay, I like that one because we're comparing 6 large to 9 small. That would match that statement that I wrote down. So I think B would be a good choice. For every 6 small, there are 9 large. Okay, well 6 small, so it looks like I'm comparing small to large. I think that should be 9 to 6, but this is saying 6 to 9. So I'm going to say that's not a true statement. And then finally, the ratio of small to large is 9 to 6. Well, I like that one because we have a small to large ratio here, and it is 9 to 6. So I'm going to say that D would be a good choice. All right. Finally, we get some fill in the blanks here. It says at the movie theater, the ratio of small popcorn sold to large popcorns was 4 to 9. So small to large was 4 to 9. For every how many large popcorn sold, 9 large popcorn sold, there are 4 small popcorns sold. So I like to write this little ratio here to remind myself of which number is which, just so I don't get confused. If it asks me about large popcorns, obviously I use the 9. If it asks me about small popcorns, obviously I use the 4. I'll just fill in the blanks there. And it says at the malt shop, ratio of hot dogs to hamburgers, was 2 to 7. 2 to 7. So for every blank hamburger sold, I'm going to say 7 hamburgers sold, there were 2 hot dogs sold. Okay? That's what I'm going to go with there. Now I did notice on this last question here with the popcorn that this ratio on the second problem would reduce. Because the multiple choices aren't in reduced form, I didn't go through the trouble of reducing the large popcorn to small popcorn, but I think a better ratio of large to small would really be 2 to 3, and small to large would be 3 to 2. Because I know 9 and 6 have a common factor of 3. 3 goes into 9 3 times, into 6 twice. So if you thought of it as a 9/6, we would be able to change it to a 3/2. Same way to 6/9, we would be able to change that to 2/3. So I like the reduced form of the ratios when you can. If it's asking you a multiple choice question, obviously, and they're not changed, then you need to just pick the best answers. Okay, so that's it for today. It's the introduction of ratios, just a comparison between two items.